macros have traditionally been used to improve performance by avoiding overhead when we do function calls. But that is a really bad reason for using them, because compilers are usually much better than programmers to decide what to inline, that means copy and paste, which behaves exactly as macros. And macros, they are obviously always, so to speak, inlined, namely copy and pasted. That's the very purpose of a macro. So if this produces more code than desired, then it's just a waste of memory, which can degrade performance. Okay, there is one reasonable use for function-like macros, and that is to compute something which must be a constant during compilation. For instance, the size of an array, for instance. If the size of an array is not simply 100 or something like that, but it should be calculated using a simple formula that and with some parameters so that it can evaluate to a constant, then we should use a macro, since we cannot use a function call in an array size for a global array, only for variable length array on the stack. So that's one good reason for using a macro. But that is a very extremely small fraction of all uses of function-like macros are for such cases. But then it's a good idea. Otherwise, it's basically forget them. It's much better to use functions and let the compiler decide what it should inline, which means basically copy and paste, just as macro expansion does. And another reason why we should not use macros, well, maybe it's a bad reason, because we should not create bugs, but if we use them in the wrong way, as I will show here, we get the wrong result. So say we want to divide 100 by the square of 10, we should get 1. But due to this macro, we will first divide 100 by 10, so we get 10, and then we multiply it by 10. So it's not what we expected. If we had parentheses around this, it would be correct. But okay, we don't. So this is the proper way to write the macro. Parentheses around each parameter when it's used, and around the entire expansion. I mean the text that defines the macro. That's the best. Okay, so what happens now if we call a square with cos x? Unfortunately, it will be computed twice. If square would have been a function, it would have been cos would have been evaluated before calling the function, and then it would be twice as fast. Some compilers can recognize that cosinus will compute the same result with the same input, but that's really not a good idea to rely on that compilers recognize that. Okay, and if we do like this, it's undefined behavior, since we modify a variable twice between sequence points, which is not permitted. Okay, say we create a macro that swaps two variables. This looks like a bad idea, and it is. Okay, so what happens? Well, if we use it in an if statement, only the temp is, only this first part is in the if, and the rest is unconditional after the if. So that's not so good, but let's put it in a compound statement or a block. It's better, but it will get the syntax error because if we have an else here, then well, it's simply a syntax error. We cannot have a block and then a semicolon and then the else. Without the else, there would be a block, and this semicolon would be an empty statement following the if, so it wouldn't do any harm. But now it's an error. Okay, so what should we do? We can do like this. And this is just by accident that this, not an accident, but I don't think the do while loop was well, I'm certain it was not created in order to write such silly macros, but this works. So if we do while 0, then we can solve both of the previous problems, as you can check by putting it and expanding it here. It will not create a syntax error, okay, it behaves as you want. And of course we need to have 0 so that we don't loop there forever.